Section 5.2, we're going to pull all those concepts and vocabulary terms from section 5.1 together and finally graph a polynomial function without our calculators. So let's recap a little bit of those concepts that were in section 5.1. So this is part 1 of section 5.2 on graphing polynomial functions. So I can ask a couple of questions. So the first question is, can the graph of a polynomial function have no y-intercept? So there is, can you draw a graph that is smooth and continuous that does not cross the y-axis? No, you can't. So all polynomial functions. So we're going to start doing some abbreviations here. So we're going to use poly for polynomial functions. So all polynomial functions have a y-intercept, and only one because they're a function, but they will have a y-intercept. Now it might be at the origin, but it's still going to cross the y-axis somewhere. Now, what about an x-intercept? So can the graph of a polynomial function have no x-intercept? Yes, we definitely can. So may have a x-intercept. So one to think about that we've already graphed would be something like f of x is equal to x squared plus 2. So we know that's our friend the parabola. It's been shifted up 2. So when you think about its graph using transformations, it looks like this, and it does not have an x-intercept. So it doesn't have to cross the x-axis. It can do all of its bending and smoothness and continuousness either above the x-axis or below the x-axis. So just to think about it. In example 1, you see 2 graphs. One graph looks like this, and the other graph looks like this. So what it's asking us is identify which of the graphs could be a polynomial function. For those that could not, or those that could, list the real zeros and state the least degree. For those that could not, say why not. So which of these is a polynomial function? Well, definitely not the first. It is continuous, but it's not smooth. It has a corner. So because of that corner, it is not a polynomial. And you're going to recognize that this was f of x is equal to the absolute value of x. And that does not fit our template. Those absolute value bars don't fit the template of what a polynomial should look like. This guy, however, is a polynomial function. It is smooth. It is continuous. It has no sharp corners. This is a polynomial function. They ask us to identify the zeros, list the real zeros. So we're going to notice that this is over here at -1. This is at +1. This is 2. So our zeros are -1, +1, and 2. And when we think about what degree it could have, we know it's going to be an odd degree because it starts below and ends above. It starts and ends on opposite sides of the x-axis, so it has to be an odd degree. The graph is crossing at each one of those zeros, which means they all have an odd multiplicity. So the smallest degree it could be would be an x from here, and x from here, and x from here. So the least degree would be x to the cube and x to the third. That could be x to the 5th or x to the 7th or x to the 9th, but it must be an odd degree. And the smallest odd degree we can do is x to the 3rd. How do I know it's not just an x to the 1st? Because it's not a line. That's how we know. Example 2, still kind of recapping from the first, from the previous section. I apologize if you can hear that background noise. The washing machine. I'm going to close the door and see if that helps. It should help. Example 2 shows us an illustration of a polynomial function. And again, your picture on the handout is so much better than mine. It does this kind of shape. It looks something like that. So again, smooth and continuous. We know it's polynomial, no sharp corners. Is the degree of the polynomial even or odd? So this is question A. Is the degree even or odd? Well, it starts above and it ends above. So because it starts and stops at the same side of the x-axis, we know it's an even degree. Part B is asking us, is the leading coefficient positive or negative? Well, because it's starting and stopping above, we know it's a positive leading coefficient. So positive leading coefficient. Again, think about just x squared being positive leading coefficient and opening and ending up. So part C is a little bit different and asks, is the function even or odd? Well, when you look at this, you should see some symmetry, and the symmetry you're going to see is over the y-axis. So because it has symmetry to the y-axis, we know that the overall function is even. So it's an even degree function, and it is an even, sorry, it's a function with an even degree, and it's an even function. Make sure I get that right. The next part on that one, part D, is asking, why is x squared necessarily a factor of the polynomial? Why is x squared a factor of this polynomial? So what we're going to notice is right here, x squared would give us a 0 of 0, and it has a multiplicity of 2. So since it has a multiplicity of 2, we know that it's going to bounce. And sure enough, here at the origin, we see the graph bouncing. So we know that x squared has to be a factor of that polynomial. And the final question asks E, what is the minimum degree of the polynomial? Minimum degree. Well, we cross once here, 2, 3. The bounce here counts twice. So 4, 5, 6, 7, 8. Let's count this again. So x, 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 x squared, x, x, x. So 1, 2, 3, 4, 5, 6, 7, 8. So the minimum degree of the overall polynomial would be x to the 8th power. So by just counting up those intercepts. So again, in this section, we're going to concentrate on actually graphing them. Your book uses a 5-step process. We're going to kind of combine the steps together, but these are the 5 steps we'll be using. So step 1, let's determine the end behavior of the graph of the function. So that comes from the power function. Where does it stop and start and stop? So is it doing this? Sorry, is it doing this? Is it doing this? What are you doing, right? Determine the intercepts, both the x and y. We're going to determine whether the real zeros, which are those x-intercepts, their multiplicities, and that will tell me whether the graph is going to cross or bounce at those x-intercepts. We're going to look at the number of turning points, then we'll pull everything together in step 5 and draw the graph. And we'll do that in the next